Hey everyone, and welcome to this video where we are going to wrap up the ideas that we discussed this week and kind of package them into one whole cool activity where all the big ideas start coming together. So first things first, what are the ideas we even covered this week, right? To remind you, on Monday we graphed polynomials and we were looking at the relationships between the number of x-intercepts and what the graph looks like. Tuesday was arguably the hardest thing we did this week. We had to solve polynomials when they were set equal to 0. And what we needed to do when we were solving polynomials equal to 0 was we needed to rewrite them in factored form. Once they were factored as far as we could go, then you set the factors equal to 0, and that actually helped us find the x-intercepts, which is what we were doing Monday. Wednesday, we didn't have any school. And then lastly, we introduced polynomial division, which is another strategy we can use in the event that something is not factorable. So, how are all these ideas related to one another? They help us come up with a better idea of what the graph of our polynomial is going to look like. We started off graphing things that were really easy, things that were graphed in factored form already, and we were able to sketch really easy polynomials. But what happens when we need to sketch a polynomial and it's in standard form? What happens when it's kind of big and none of our factoring strategies work? Well, division helped kind of like tie everything together. So that's what we're going to do today. We are going to connect the dots. This is just a quick review of what we're about to do in 2 examples, but essentially connecting these three ideas together, we can split it into 4 parts. Part 1, dividing the polynomials. We can divide the polynomials, and if we get a remainder of 0, the factor theorem says that we found a factor. Well, if the remainder is 0, then we can write our polynomial in factored form. Once it's factored, we're going to continue factoring until we can't anymore. Oftentimes, the quotient needs to be factored more, and we're going to keep factoring until we can't anymore. Once it's been completely factored, now we're ready to solve for our x-intercepts. How did we solve for our x-intercepts? We set the factors equal to 0. When we set the factors equal to 0, we're looking for when the y value is equal to 0, which happens at the x-intercepts, and that will help us get those. And once we have them, then we can plot them on our x-axis. We can look at the degree, determine the end behavior of our graph, take a quick second to think about multiplicity, figure out if we're going to have a bounce or a snake, and boom, we can sketch our polynomial really quick. And that is precisely what I intend to have us practice today. So grab your notes. We are going to do the first 2 examples together. The other 4 problems on there are going to become homework, but they are very similar to the 2 problems we are going to do together. So grab your notes, meet me back here. All right, example number 1 says x to the 4th plus x to the 3rd minus 11x squared minus 9x plus 18 divided by x plus 2. Again, remember, what we want to do is divide the polynomial, write it in factored form, keep factoring, set the factors equal to 0, get the x-intercepts from setting the factors equal to 0, and then sketch. Like, that's the goal of the problem. So first things first, we got to start with dividing polynomials. And if we're going to start with dividing polynomials, we're going to use the strategy that we just went over, which was the box method. More of a rectangle, but start off with your box. Since our dividend has 1, 2, 3, 4, 5 terms, I need to make sure it has 5 columns like so. And we're going to split our box in half using the divisor x plus 2. We will start by writing x to the 4th inside of the box, and now we're in multiplication land. So x times what value gives you, when they're multiplied, x to the 4th, the thing inside of the box, and that would be x to the 3rd. Once we have the number written on top of the box, we multiply it. X to the 3rd times 2 gives us 2x to the 3rd. Now we look and we see that, hey man, I have 2x to the 3rd, but I need just 1x to the 3rd. I need to take away 1x to the 3rd, and I will fill it inside my box. And now I'm ready to figure out what multiplies. X times negative x squared gives me x to the 3rd. Negative x squared times 2 gives me negative 2x squared. I look at my polynomial and I realize, hey, I have negative 2x squareds, but I need negative 11x squareds. So that means I need to take away 9 more x squareds. Now I say x times negative 9x, that multiplies to give me negative 9x squared. Negative 9x times 2 is negative 18x. And I look at my problem. I say, hey, I need negative 9x and I have negative 18. I need to add 9x to make it match my dividend, my original polynomial. Then I say x times 9 gives me 9x. 9 times 2 gives me 18. What do I need to have as my constant term? Oh, it's 18. That means I don't need to add anything. And my remainder is 0. Since the remainder is 0, we have found a dividend. So what this means my original polynomial, x to the 4th, plus x to the 3rd, minus 11x squared, minus 9x plus 18 can be rewritten in factored form as my divisor, what I divided my equation by, x plus 2, since it's a factor, multiplied by my quotient, x to the 3rd minus x squared minus 9x plus 9. So I just rewrote my original polynomial in factored form. I started to factor by using division. That's pretty crazy. So now that I have it factored, I need to keep factoring more. Notice that the divisor, what we started with, this guy is simplified fully. I'm not going to need to factor that anymore. This one's good. No additional work to be done here. However, the quotient could use some work. The quotient, actually, it has 4 terms. That means we could use factor by grouping. So let's try it. X to the 3rd minus x squared. That has x squared in common. And then I have x minus 1 left over. Let me try factor by grouping on the right. I can factor out a negative 9, and that will give me x minus 1 on the right. Since these two pieces match, that means factor by grouping works. So I can rewrite this as x squared minus 9. The parts outside of the parentheses go together. X minus 1. The part inside the parentheses get written one time. And don't forget the x plus 2 that we started out with. That guy stays out here. So I took my factored form from division, and I'm factoring the quotient. I'm factoring the bigger part again. Then I got to ask myself, can I keep factoring this? Can I keep going? Is it possible? So again, remember that we said the x plus 2, that guy is good. That's good to go. But x squared plus 9, is this piece factorable? Let's see, is there a GCF? No. Is it a difference of squares? Is it a perfect square minus a perfect square? Oh yeah, actually it is. So I can rewrite that equation. I can kind of think of it 2 ways, but I can rewrite that equation. Remember, this is x times x, 3 times 3. I can rewrite that as x plus 3 times x minus 3, the x squared minus 9. This guy drops down, our x plus 2. And this x minus 1, this one was good too, x minus 1. Basically, you'll know you've factored all the way when all of the terms down below are just x, not x squared, not x to the 3rd. That is your big hint that you cannot factor anymore. So now that I have my original equation factored completely all the way, now I need to find my x-intercepts. And the way I find my x-intercepts is I set each factor equal to 0. So I'm going to start with x plus 2. Set it equal to 0 and get x alone. Take away 2 and you'll find out that, hey, we have an x-intercept at negative 2. Nice. Then I move to my next factor. I have x plus 3. Set it equal to 0, do a little arithmetic, you get x equals negative 3. Nice. Then I'm going to set my next factor. Since it's all factored out, it's pretty straightforward. I just set x minus 3 equal to 0, because when I set it equal to 0, I find my x-intercepts. Add 3 to both sides, I get x equals positive 3. Nice. And lastly, I'm going to set x minus 1 equal to 0. Do a little arithmetic, I get x equals positive 1. Check it out. I found all 4 of my x-intercepts by setting each factor equal to 0. And now I just need to consider a couple things. Thing number 1 I need to consider is, what's the degree of this polynomial? And you can look in 2 different places. You can look at the highest exponent in standard form and see that that's degree 4. Or you can count that there is 1, 2, 3, 4 x's in completely factored form, which matches. Remember, 4 is even, which means my end behavior is either up, up, or down, down. I just need to decide based on the leading coefficient. I look back at my original problem and I realize that it's positive over here, which means my end behavior is going to go up, up. I'm choosing this one. And before I do anything else, I'm going to look and say, are any of these x-intercepts the same? Do any of them have a multiplicity that's going to cause a bounce or a snake? And I've got -2, -3, +3, +1. There is no multiplicities right now. Once I've figured all this stuff out, it's time for me to sketch. On my blank xy plane, I know that I'm going to need to graph -2, -3, +3, and +1. Make sure that you label the axes since they're blank, and we'll put a spot at each x-intercept. One at -3, one at -2, one at +3, one at +1. And remember that we said our end behavior was up, up. Since there are no multiplicities, it's like a line. It's going to go from one side to the other, has to turn around one side to the other, has to turn around one side to the other, has to turn around one side to the other. And this makes sense. We said it was degree 4. They look like W's or M's. This definitely looks like a W. That's crazy. We did it. Let's do another example. Okay, we have 2x to the third minus 15x squared plus 24x plus 16 divided by 2x plus 1. Again, we're going to start by dividing the polynomials, and that will give us factored form. Then we're going to keep factoring until we can't factor anymore. Then we're going to set the factors equal to 0 to find the x-intercepts, and then we're going to put all the information together to sketch a graph. Let's start with the box method for division. I notice I have 1, 2, 3, 4 terms in my polynomial or my dividend. So I set up my box to have 4 columns. This time my divisor is 2x plus 1, so that goes on the outside. My first term, 2x to the third, always starts on the inside. And now I'm ready to write values on the outside of the box that multiply to give things inside the box. 2x times x squared gives me 2x to the third. Continue multiplying and I will get x squared. I look and I have 1x squared and I need to have -15x squared. So I got to take away 16x squared. Now I've got something in the box. I need to write something on the outside of the box. 2x times -8x gives me -16x squared. Now it's outside. Multiply -8x times 1 gives me -8x. So I have -8x, but I need 24x. So that means I'm going to need to add 32x. 32, what 2x times what equals 32x? That's going to be 16. I don't need an x because it's already accounted for in red. 16 times 1 gives me 16. Oh, look, that was the last term anyway. so I don't need to add anything, which means my remainder is 0. By the factor theorem, since the remainder is 0, I just found a factor. The divisor is a factor of the dividend. Again, this means 2x to the third minus 15x squared plus 24x plus 16 is actually equal to these two polynomials multiplied together, 2x plus 1, and my quotient, x squared minus 8x plus 16. Again, I rewrote my original polynomial p of x, my dividend, as I broke it up into multiplication in factored form. Nice. Now that I have it factored, I need to keep factoring. Notice that my first equation, 2x plus 1, that's just 1x. That means we're good to go. But now we need to factor the quotient, x squared minus 8x plus 16. So this, we have to go back and think about all the strategies we have. Is there a greatest common factor here? No, there's not. Is this a difference of squares? No, it's not. Is it a sum or difference of cubes? No, it is not. Can I use factor by grouping here? No, I cannot because it doesn't have 4 pieces. Do I need to use X box or X here? Yes, I can. I ask myself, what multiplies? This is like 1 times 16. What multiplies to positive 16 but adds up to negative 8? And that would be negative 4 times negative 4, man. Which means this whole equation, the quotient, can be factored into x minus 4 times x minus 4. Don't forget the 2x plus 1 that we had. It doesn't go away. So this is just 1x, 2x plus 1, can't not be factored anymore. X minus 4, it's just 1x, it cannot be factored anymore. This is x minus 4, just 1x, it cannot be factored anymore. This is as far as we can go. Once we have gone as far as we can go, we need to find the x-intercepts. How do we find the x-intercepts? We set the factors equal to 0. Any factor you have, set it equal to 0 and try your best to solve for x. So we'll start. We're going to set 2x plus 1 equal to 0. If I take away 1, I have 2x equals negative 1. I need to get x alone. I can divide both sides by 2. And I get x equals negative 1/2. It's a little weird, but it's allowed. Then I'll set my next factor, x minus 4 equal to 0. I add 4 to both sides and I get x equals 4. Nice. I love it when they're simple and they work out like that. I'm going to set my other factor equal to 0. I need to set each and every single one equal to 0, even if they're the same. The reason I want to do this is because it's important, because I will put that together when I go to graph, meaning I've got some multiplicities going on here at x is equal to 4. I have 2 of the exact same intercepts. So just as a little note to myself, I'm going to write that this has a multiplicity of 2, right? 4 has a multiplicity of 2, which we know if the multiplicity is even, that's going to cause a bounce on the graph. If the multiplicity was odd, like 3, 5, 9, that's when we're going to get some sort of snake. Now that we've got our polynomial written in factored form, we set our factors equal to 0, we have our x-intercepts, we're ready to draw a quick sketch. So, first things first, we got to figure out the degree. What is the overall degree of this polynomial? I can look at standard form and it's the highest exponent of 3, or I can look back at factored form and count the number of x's. 1, 2, 3. 3 is odd, means my end behavior is going to be opposite. It's either going to be up, down, or down, up. To decide which one it is, I look at the sign of the polynomial. Is it positive or is it negative? It's positive, which means it needs to end positively, and so my end behavior will be down, up. Remember, we do have a multiplicity. It's right here. Since my factors are repeated, this means 4 has a multiplicity, How many times did I write it? 2 times, which is going to result in a bounce on my graph. And that's important because if I don't account for that, I'm going to get all sorts of messed up. Now I'm ready to put my x-intercepts on the graph. I have an x-intercept at -1/2, and I have two x-intercepts at +4. As long as I label the x-axis, spacing isn't too particular, and I've got just a regular dot at -1/2, and at 4, remember, since we have that multiplicity, I like to write a little b there to myself to remind myself that I need to bounce. Then we can apply our end behavior. Remember, it says that we need to go down first and then up to end. And since -1/2 doesn't have any crazy multiplicity, cross through, go up as high as you want, but at 4, it's got to bounce. 4 has to do this shape. Boom. And that matches a quick sketch of our graph. Okay, so I hope you still have that piece of paper. Remember, you can pause, rewind, go back, look at anything you need in this video. But the next 4 examples are for you. They're homework problems. They are going to behave just like the 2 examples we did together. And you're going to follow the same 4 steps. Start by polynomial division, then factor your quotient more until you cannot factor anymore. Set the factors equal to 0 to find your x-intercepts, and then use the information you need to graph a quick sketch of the polynomials. I hope this was helpful. Remember to use all of your resources, ask questions amongst each other, and I hope you have a great day. Toodles!